And today's topic is statistics for artificial intelligence, AI. Okay, let's go to material for today. So, Kobayashi YouTube University of Science and Technology. Today is the fourth delivery. So today's content is statistical analysis, number 1. Mathematical basics, fundamentals for artificial intelligence, AI. So recently, many people are studying and using it in their actual job, artificial intelligence. So when we talk about artificial intelligence, usually we use the word machine learning, and deep learning is included in the machine learning. Okay. So in the basics of machine learning, probability and statistics are the fundamentals for AI. It says so. So today, the first step for statistical analysis on normal distribution, standard normal distribution. Okay. Oh, my name is Hideo Kobayashi, by the way. I run my company in Japan. I work for engineering consultant, and also I do a lecture of many seminars, such as technical seminars, math seminars, and technical English seminars, and so on. And I'm also the part-time lecturer at Graduate School of No.1 University. So this broadcasting is from Odawara City, Kanagawa Prefecture, Japan, to the world. Okay, let's go to the next slide. Okay. Number 1, normal distribution to standard normal distribution. Okay. When we deal with normal distribution in mathematics, we usually deal a standard normal distribution, not normal distribution. Because when we say just normal distribution at that time, this is expressed in math symbol like this. And this N stands for normal distribution. And in parentheses, mu, either mean. Sigma squared is a variance. So these two are used variables. So when we deal with a lot of data of the time, we'll have in statistics lots of normal distribution diagrams depending on each data, each one set of data. So it's a nuisance to calculate. So the clever in ancient time thought, a clever man, in many years ago, maybe more than 100 years ago, thought of standard normal distribution, not normal distribution. This standard normal distribution means, so standard means, okay, mean equals 0. Variance equals 1. 1 squared is also 1, okay? Then we have lots of normal distribution diagram depending on each set of lots of data. So at the time, as I explain now, this normal distribution data is expressed n mu sigma squared. But when we normalize this one, standardize this one, like standard normal distribution, then mean becomes 0. Variance becomes 1. So it's very easy to treat in math. So when the lot of data obeys normal distribution, in that case, the distribution graph is like this red curved line. Okay? X-axis and data value. Okay? Fx means frequency of x. Okay? How many times x occurs. Okay? So mu, mean, and sigma, standard deviation. Mu plus sigma, mu minus sigma comes here. Okay? Then from this set of data, we do the calculation minus mu. Then by minus mu, okay, this mu becomes 0. In this case, mean value becomes 0. Okay, and mu plus sigma becomes sigma. Mu minus sigma becomes minus sigma, and it comes like this. Then divided by standard deviation sigma. Then this curved line becomes the right one. Right one is this one, mean value. Oh, sorry. This graph. Just not so good. Not right. Mu 0 comes here. 0 comes here. And here plus 1, minus 1. Okay. As for standard deviation. Okay. So from data set X, we change X to Z. Z equals X minus mu over sigma standard deviation. Okay. Then the graph becomes like this. Okay. I'd like you to make a correction as I explain now. Okay. Then this total area under the curved line, the area is set to 1. Just the adjustment is made to become the total area 1. So area means probability. Okay. So in normal distribution, the fx for normal distribution equals this formula. Rather complicated. Okay. Then we use a new parameter z instead of using x. Then this equation for normal distribution is changed to this one. So this equation, this formula shows a standard normal distribution. Okay? So when we use normal distribution in statistics, at that time we usually use standard normal distribution, not normal distribution. Okay? Then go to next slide. Okay. From now, using the knowledge, math knowledge, I explain now. Using that knowledge, I'd like you to solve this solved problem 1. The problem is the lifetime of light in bulbs is known to be normally distributed with mu equals 100 hours and sigma equals 8 hours, where mu expresses mean, sigma expresses standard deviation. Then what is the probability that a bulb picked at random will have a lifetime between 110 and 120 burning time, burning hours? Okay. So we are asked here to find P, parenthesis 110 to 120 as for X. Okay. P means probability. Okay. Where X refers to time measured in hours of burning time. So now in the problem, we get mu 100 hours and standard deviation 8 hours, and letting X1 110 hours and X2 120 hours, then we get Z1 equals X1 minus mu over sigma. Then this one becomes 110 minus 100 over 8 equals 1.25. Z2 equals X2 minus mu over sigma equals 120 minus 100 over 8 equals 2.50. Thus, we want the area probability between Z1 1.25 and Z2 2.50. This one. And here, the shaded area. This shaded area means probability from X equal is 110 to 120. Okay. So looking up Z2 2.50 in the table of proportions of area for the standard normal distribution. So this table is on next page. I listed here. Okay, we use this one. This one, standard normal distribution table. And this probability is given from center value to a certain area. Okay. We get 0.4938, Z 2.50. Okay, let's check it. 2.50, 2.50, yeah, 0.4938. So 0.4938, it's written here. So this is the value from the table I explained now. This is the area from Z equals 0 to 2.50. 0 to here. I'd like you to look this figure, 0 to 2.50. but we'd like to get this shaded area. So we have to do from this area minus this white area. Then we can get this shaded area probability. Okay. Then looking up Z1, 1.25, 1.25, we get 0.3944. Okay. Let's check it in the table. 1.25, 1.25, 0.3944. Okay. 0.3944. It's a value from the table. This is the area from Z equals 0 to Z1 equals 1.25. Okay. So suppose subtracting 0.3944 from 0.4938, then we get 0.0944. Oh, sorry. Oh. Then we get 0.0944. And this means 9.94%, 9.94%. For the shaded area, that gives probability X is within 110 to 120. Okay, this is the answer to this one. Okay. So this is the end of today's explanation. Okay, that's all for today. Thank you very much. Next time. Bye.